section 13.1 is on measures of central tendency. So what is central tendency? Well, this entire section, what I'm going to be highlighting to you is essentially this is what you guys know as the word average. A central tendency is where's the middle of something. And when I say average, for instance, if I said what is the average test score, most certainly almost all of you would add up all the test scores divided by the number of students. Well, that is one measure of the word average, or that is one measure of central tendency. That is called the arithmetic mean. That is what you guys usually know as an average. But adding them up and dividing them by the number the mean is not the only measure of finding the middle of something. The ones that we're going to learn in this section are mean, median, mode, and then there is something called a mid-range, but we're also going to learn a weighted mean, which is really important when you want to find out what your GPA is. So, most of you have already seen this. Most of you already know how to do this. Our calculator can help us out on this one, so I definitely want you to get comfortable using your calculator, using the table feature in your calculator in this one. But I'm going to go through this and show you how to do it all and what work I expect to see when you're doing your notes. So the first thing we know is the arithmetic mean. So it says statistics. We've already read this before. It says statistics involves the collection, organization, summarization, presentation, and interpretation of data. The branch of statistics that involves the collection, organization, summarization, and presentation of data is called descriptive statistics, and that branch that interprets and draws conclusions is called inferential statistics. So when we're drawing these conclusions, it's technically called inferential statistics. It says, one of the most basic statistical concepts involves finding measures of central tendency of a set of numerical data. It is often helpful to find numerical values that locate, in some sense, the center of the set of data. Suppose L is a senior at a university. In a few months, she plans to graduate and start a career as a landscape architect. A survey of 5 landscape architects from last year's senior class shows they received job offers with the following yearly salaries. The first one's $43,750. Next is $39,500. Next is $38,000. Next is $41,250. And the last is $44,000. So if it looks to me, it looks like the low here, just eyeballing this, looks like the low is about the $38,000. And the high salary that I'm seeing here, I see one that's up to $44,000. So the high, so the question would be, what should Elle expect when she's going to interview, or what kind of job offer should she expect? So you would expect that she would have at least a $38,000 offer, because that was low, and probably at most a $44,000 offer, because that was the high. Maybe it changed a little over the year, but not significantly. But should she expect on getting one of those two salaries, or maybe somewhere in the middle? And that's where we want to talk about central tendencies. It says before Elle gets interviews for a job, she wants to determine an average of these 5 salaries. This average should be a central number around which the salaries cluster. We will consider 3 types of averages known as the arithmetic mean, the median, and the mode. Each of these averages is a measure of central tendency for the numerical data. The arithmetic mean is the most commonly used measure of central tendency. The arithmetic mean of a set of numbers is often referred to as simply the mean, which you guys know it as is the word average. To find the mean of a set of data, find the sum of the data and divide it by the number of data values. That's an important sentence right there, so I'm going to go ahead and add it, because that's what it is in English. To find the mean of a set of data, find the sum of the data values and divide it by the number of data values. Okay? So it says, for instance, to find the mean of the 5 salaries listed above, Elle would divide the sum of the salaries by 5. So you can see in the little picture it says mean equals, they added those 5 salaries that we talked about, because there was 5 of them, they divided it by 5, and she had a mean salary of $41,300. It says the mean suggests that Elle can reasonably expect a job offer at a salary of about $41,300. So that's how much she should expect to make when she gets her job and graduates. It says in statistics, it's often necessary to find the sum of numbers. The traditional symbol used to indicate the summation is the Greek letter sigma. So let me highlight that sigma there. It's that capital E looking thing. That's sigma. Sigma stands for sum. That's Greek letters. Thus, the notation sigma x, called summation notation, denotes the sum of all the numbers of the given set. We can then define the mean using summation notation. This is on the top of the next page, but let's go ahead and talk about it now. So what would we do? If we wanted to add the values, we would write sigma x, and then if we want to divide it by the number of values they always say, it's typical in mathematics to use the letter n being the number of items that there are. So here they're going to say the mean is equal to the sum of x, the sum of the data, divided by the number of data. So sum of x divided by n. No, you do not need to use this notation. You just need to be able to calculate the mean.